Welcome to this explainer. Today, we're zooming in on the hidden risks of firmware. It's this invisible layer of code that runs practically everything we touch, but its inherent fragility puts our hardware, our data, and honestly, our daily routines in serious jeopardy. To kick things off, picture this incredibly frustrating moment from embedded systems expert Jacob Benigo. He's standing in his home ready to use his treadmill, something he uses almost every single day. Out of nowhere, bam, it forces a firmware update on him. No skip button, no remind me later, just an update he has to sit through. But then, total failure. The screen just hangs there with a retry button that absolutely refuses to work. Every tap, just a useless beep. The update completely locked up, turning a very expensive exercise machine into what is basically a giant, heavy brick, or, a really expensive coat rack.
Section 1. The silent hardware threat and the invisible software bridge.
That treadmill disaster perfectly highlights why we absolutely cannot ignore this invisible software bridge. According to the 8200 Cyber Bootcamp, firmware is this highly specialized software living in non-volatile memory. That just means it remembers its code even when you yank the power cord. It is the absolute essential glue holding your physical hardware and your higher-level operating system together. So when this firmware gets corrupted, meaning the code is damaged or weirdly altered, that bridge totally collapses. And the result? The device malfunctions, loses critical data, or just straight up refuses to boot. It's completely dead in the water. Moving on to Section 2, Causes of Firmware Corruption, the lab versus the real world. Now, this creates a massive engineering dilemma. See, developers usually design and test these firmware updates for what they call the happy path, basically a pristine lab environment. In the lab, you've got perfect power, flawless downloads, and entirely controlled updates. It's a developer's dream. But the real world is messy. Real-world firmware has to survive sudden power cuts, half-finished downloads from terrible Wi-Fi, hardware that's falling apart, and, let's be honest, highly impatient users who will just pull the plug when an update takes too long. The 8200 Bootcamp breaks down the real-world culprits here. Something as simple as a random lightning strike during a routine BIOS update can leave your firmware half-written, meaning the device just can't boot. But we're not just talking about bad weather. We also have to worry about advanced persistent threats, or APTs. These are highly determined, usually state-sponsored hackers who deploy incredibly sophisticated malware to completely bypass your normal OS security and inject bad code straight into the firmware itself. Toss in everyday physical damage, component aging, and manufacturing defects, and you suddenly realize just how terrifyingly vulnerable this hidden layer really is. Which brings us to Section 3, the hard drive dilemma, when smart drives act dumb. Nowhere is this fragility more ironic or frankly more suspenseful than inside modern hard drives. A really fascinating white paper by Gilware Data Recovery calls this the HDD OS because your hard drive is literally a tiny computer living inside your main computer. This mini brain is working behind the scenes 24/7, managing incredibly complex stuff like zone tables, defect lists, read-write calibrations, and data addressing. It's constantly tweaking things to optimize performance and keep the drive healthy. But here is the ironic, tragic chain reaction that can happen. Modern drives use smart technology. That's self-monitoring, analysis, and reporting technology. When a drive feels some of its sectors failing, it panics and tries to save itself by logging those errors into its internal smart tables right on the physical platter. But writing all those logs takes time. Meanwhile, you, the human user sitting at the keyboard, are experiencing absolutely severe lag. Your system is freezing up. You get frustrated, right? So what do? You do a hard shutdown, or you literally yank the power cord. And because you cut the power while the drive was mid-write to its own operating system, you just inadvertently scrambled the drive's brain. Get this. That exact scenario is so ridiculously common that a full 10% of the dead drives Gilware sees in their lab have absolutely perfectly healthy internal electronics. The read and write heads are fine, the user data is entirely intact, the hardware is fully functional, but it's completely inaccessible all because of one corrupted firmware bug. 10%! That is wild. So, Section 4, Designing for Graceful Failure, Building in Failsafes. Because the real world is so chaotic and because we are all so impatient, how do we actually stop our devices from turning into expensive paperweights? Well, Jacob Benigo made a really profound point after he analyzed his whole treadmill nightmare. He said the goal of a firmware update mechanism isn't actually just to succeed, it's to tolerate failure gracefully. Think about that. If an update mechanism literally cannot handle a failure, then the product has zero chance of surviving the realities of the field. To pull this off, developers have to build bulletproof fail-safes right into the device's architecture. A massive one is using dual image bootloaders, or AB partitions. It's basically giving the device a backup brain. So if a new update is interrupted or fails its validation check, the system just automatically falls back to the old known good backup. No harm done. Devices should also be smart enough to double-check their own power levels and connection stability before they even think about starting an update. And engineers, they need to ruthlessly test for the worst-case scenarios. They need to literally simulate yanking the power cord during a bad download to make sure the device can fix itself automatically, without forcing you to sit on hold with customer support for 3 hours. And on the cybersecurity side of things, the bootcamp strongly recommends hardware-based zero-trust strategies. This involves using Trusted Platform Modules, or TPMs. You can think of a TPM like a massive, strict bouncer at an exclusive club. It cryptographically checks the digital ID of any firmware code before it is ever allowed to run. If the code is corrupted or injected by malware, the bouncer stops it right at the door.
All right, Section 5. Can we fix it? The intricate art of data recovery.
Because we really have to ask the big question. What actually happens when all those failsafes are missing? The update crashes and your most critical drive goes completely dark. When you hit that wall, you have to turn to a highly specialized, almost magical field of reverse engineering. You have to rely on experts at recovery labs like Gilware who actually know how to dive deep into a dead storage device's damaged operating system and manually manipulate the raw code. These recovery engineers are pulling out incredibly advanced tactics and specialized hardware toolkits like the PC3000 to essentially trick the broken drive. For instance, if a drive is failing its own initial diagnostic check and refusing to boot, they can rewrite the OS to just ignore the check entirely. It's exactly like a mechanic bypassing a faulty check engine light so you can at least limp the car to the shop. They can even manually intervene to stop the drive from endlessly spamming its own smart tables, stopping it from literally suffocating on its own error logs. By doing this, they stabilize the drive just barely long enough to extract all that priceless user data trapped inside. But listen, this is not something you just learn on a weekend. This work requires a deep understanding of hexadecimal math, multi-threading, and some incredibly obscure computing concepts. It is so intensely complex and the industry is so secretive that Gilware estimates fewer than 300 humans worldwide have put in the 10,000 hours of practice required to truly master this level of firmware manipulation. 300 people. It's this tiny elite group of experts standing between us and permanent data loss. So as we wrap up this explainer, I want to leave you with something to really think about. Firmware is this silent, fragile bridge that is literally holding your entire digital life together. So the next time a progress bar stalls out on your screen, or the lights in your house flicker right in the middle of a major update, ask yourself, are you confident your device was built to survive the messy real world? Or is it just sitting there, waiting to become a brick?